DEKWP, 小攻 Abor. Your learning journey starts now. Ever wonder how you know where you are, down to the last centimeter? Your brain's got a built-in GPS system, way more sophisticated than your phone's. It's not just one thing, it's a whole network of specialized neurons working together. So, how does this brain GPS work so well, using barely any juice? Think of it like this. First, there's this cool theta rhythm, like a tiny metronome ticking away 4 to 12 times per second. This helps pack spatial information super efficiently. Second, it's constantly updating its map using Bayesian logic, mixing what it sees with how it's moving. And third, it's got foresight. It can even predict where you'll turn your head before you actually do. All this teamwork means it builds a stable map while sipping energy, around 20 watts, that's less than a dim light bulb. Robots? They guzzle power for similar tasks. Nature's an engineer, folks. Now, let's zoom out. How does this raw data become purposeful action? Enter the DIKWP model. Think of it as climbing a ladder of understanding. D is the raw data, what your sensors or eyes pick up. I is when you extract meaning, like recognizing a landmark or tagging a location. K is building knowledge, your internal map, understanding the structure and rules. W is wisdom, making smart decisions based on that map, like choosing the best route or predicting what happens next. And P, that's purpose, the ultimate goal, like get to the exit or avoid that obstacle. It's a chain. Data becomes information, which becomes knowledge, leading to wisdom, all aimed at fulfilling a purpose. Simple, yet powerful. Okay, let's pit our brain against the current AI. AI systems are great at mapping environments using techniques like SLAM, but they often need tons of computing power and are pretty rigid. They excel at geometry but struggle with the why behind navigation. Our brain, however, is a marvel of efficiency and flexibility, using those grid cells and constantly thinking about the goal. The big gap. AI lacks that innate, low-power grid cell system and that deep, purpose-driven logic. But here's the exciting part. By weaving in ideas like DIKWP and semantic math, we can potentially build AI that navigates not just accurately, but intelligently and efficiently, much closer to us. This leads to a really cool concept, the semantic tension field. Forget space as just empty space. Imagine it as a dynamic field, constantly shaped by your goals. Think of intent as a force. When your current situation doesn't match your goal, that creates tension. Like wanting to escape a maze, your goal actively biases how you perceive the space, making paths towards the exit seem more attractive. Navigation then becomes less about finding a path, and more like flowing naturally towards your purpose, guided by this internal tension field. Pretty mind-bending, right? So, where does this leave us? The future of navigation isn't just about getting from A to B. It's about creating systems that understand space semantically, rich with meaning, not just lines and angles. It's about being truly purpose-driven, where every decision is informed by the ultimate goal. And hopefully, it leads to AI that can explain its reasoning, showing why it chose a certain path. The dream? Building machines that navigate with the same blend of efficiency, flexibility, and goal-oriented intelligence as our own amazing brains. That's the journey ahead.